Hello students, today we are going to see topic Fourier series. Already in the previous lecture, I've given you the introduction and a problem in Fourier series. Just as a recap, you know that Fourier series is used to convert a periodic function to a continuous function. In the next module, you will be learning wave and heat equation where you will make use of this Fourier series. Okay, now we are going to see another problem in Fourier series. Find the Fourier series for f of x is equal to x minus x square, where x lies between minus pi to plus pi. Here in this problem, your limit is from minus pi to plus pi. By the definition given you earlier, if your limit varies from 0 to 2 pi or minus pi to pi, you call this Fourier series as full range Fourier series. And the formula for full range Fourier series is f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos nx plus summation n is equal to 1 to infinity bn sin nx. So here in our problem, we are given f of x is equal to x minus x square. So just we are going to replace this f of x by x minus x square. So now our formula will be like this. So the ultimate aim in this problem is that finding the values of a0, an and bn. These terms a0, an and bn are also called as your Euler's formula. Okay. So now coming to your a0 is given by using the formula a0 is equal to 1 by pi integral over f of x dx. So this is your formula for finding your a0, f of x into dx. Okay. So now, in the given problem, your f of x is nothing but x minus x square. So I'm just writing integral over x minus x square into dx. And also your limit is from minus pi to pi, so I apply the limits. Now, integration of x is x squared by 2 and integration of x squared is x cubed by 3. Now I'm going to apply the upper limit and the lower limit. So here I have pi squared by 2, that is instead of x I will apply the upper limit minus pi cubed by 3 minus the lower limit. So here I have instead of x I replace it by minus pi the whole square by 2 and instead of x cube I replace it by minus pi the whole cube by 3. Okay, now what I do is, we know that minus pi the whole square is minus pi into minus pi, so it will be plus pi. Plus into minus will become minus, so it will be minus pi square by 2. And here you have minus pi the whole cube. Minus pi the whole cube, that is 3 times of minus pi will be minus pi. Minus pi cube into minus will become plus pi cube and into minus will become minus pi cube by 3. So now we get something like this. Here you can see you have pi squared by 2 and minus pi squared by 2. So these two terms will get cancelled. So the remaining terms will be 1 by pi minus pi cube by 3 minus pi cube by 3 is minus 2 pi cube by 3. So one of the pi and one of the pi will get cancelled. So you will get your a0 to be minus 2 by 3 pi squared. Okay. So now first we have finished what is our a0. Next we have to find this, what is our an and bn. Now going to an. The formula for finding your an is 1 by pi integral f of x cos nx dx. So here in the problem, your f of x is nothing but x minus x squared into cos nx dx. Here also we will apply the limits from minus pi to pi. Here you can see that under the integration you have two terms. One is the algebraic term and one is the trigonometric term. So we either use integral over u dv or we use the Bernoulli's formula. Here I have used my Bernoulli's formula and a shortcut method which was taught in your class. I am using it here. Okay. So now you can see that the algebraic term stands first before my trigonometric term while writing my eyelet. So I choose my u to be an algebraic term, that is x minus x squared. So I find the first derivative, I get 1 minus 12 I find the second derivative, I get minus 2. And while finding the third derivative, it becomes 0. So when I get 0, I'll stop here. Now I'm going to integrate the remaining term. That is, when x minus x squared is considered, the left term is cos nx dx. Okay, now when I integrate this, I'll get sin nx, and again by chain rule, I get divided by n. Likewise, when I integrate my sine, I'll get minus cos nx by n squared. Again, I integrate, I'll get minus sin nx by n cube. Now you can see what I've done is I've just paired these two terms together, these two terms together, these two terms together with alternative signs. So I'll be having something like that, that is an is equal to 1 by pi into x minus x squared into sin nx by n. You can see here, that is 1 by pi into x minus x squared sin nx by n. Next term, you can see here I have a minus. In this term also I have a minus. Minus into minus will become plus. So it will be 1 minus 2x into cos nx by n squared. Okay. And the third term also, it will be minus into minus will become plus 2 into sin nx by n cube. And the limit would be minus pi to pi. So we already know that sin 0 is 0, sin pi is 0, sin minus pi is minus of sin pi, which is equal to 0. And also we know that sin n pi and sin n minus pi is also 0. So when I apply the limits pi and minus pi to these two terms, that is where I have sin, these two terms will become automatically 0. So what I do is, in order to avoid the confusion, I'm just going to eliminate these sine terms and I'm just going to write the cos terms. Okay, that is, I'm going to rewrite this equation as an is equal to 1 by pi 1 minus 2x cos nx by n squared, and the limit from minus pi to pi. I hope you understood. Okay, now what I'm going to do is, in the place of x, I'm just going to replace pi. So I'll be having 1 minus 2 pi cos n pi by n squared and minus the lower limit. So wherever I'm having x, I'll replace it by minus pi. Okay. So now again what I do is, in the place of cos n pi, you know that cos n pi is minus 1 power n by n squared, and here this minus is multiplied here, it will be 1 plus 2 pi cos n pi, that is cos of minus theta is cos theta, so I'll get cos n pi by n squared. Here again, instead of cos n pi, we substitute minus 1 the whole power n, so I'll get something like this. You can see here, minus 1 the whole power n minus 1 plus 2 pi minus 1 the whole power n. So you can see both the terms are having minus 1 power n as a common term. So I just take minus 1 power n outside. So it will be 1 minus 2 pi minus 1 minus 2 pi. So plus 1 and minus 1 will get cancelled. So you will be having minus 2 pi minus 2 pi as minus 4 pi. Okay, so now this pi and this pi will get cancelled. So we will be having minus 4 minus 1 to the power of n by n squared. So we have finished with an. Still our problem is not yet over. We have to find what is of bn. The same procedure whatever we did for an, we will do it for bn also. So the formula for finding our bn is 1 by pi integral of f of x sin nx dx. So here in this problem again, our f of x is nothing but x minus x squared. So we get it as bn as 1 by pi minus pi to pi x minus x squared sin nx dx. Again, you see it is a product of two functions. One is an algebraic term and one is a trigonometric term. And in highlight, the algebraic term stands for. So, you will choose it as x minus x squared. We'll find the derivative until it becomes 0. Now, the remaining terms we consider as 0 and we'll find the derivatives. Sorry, we integrate it. So, integration, we'll get minus cos nx by n. Second derivative, second term integrating, you'll get something like this, that is minus sin nx by n squared. And third integration, you'll get cos nx by n cube. So again, I'm going to pair with alternative signs, so I get something like this. As I told you, when you apply sin n pi or sin n minus pi, both the terms will become 0. So I'm just going to omit the sign term and I'm going to rewrite my equation like this. Okay. So now what I'm going to do is wherever I'm having x, I'm going to replace it by pi. So when I replace it by pi, I have something like this. And also cos n pi, cos n minus pi, I know it is minus 1 power n. Okay, so now what I do is, I just multiply this minus inside. So minus into minus. So this equation, first I'll just do minus with this term. So this will be minus x, so it will be plus x. When this minus is multiplied here, this term will be minus pi. Minus pi into minus will be plus pi. So here you will be having plus pi, and this term it will be pi square. So it will be plus pi square. When you multiply this with this minus, it will be minus pi square. Again you multiply with this, it will be minus pi squared. And here minus into minus will be plus 2 minus 1 power n by n cube. So now what will happen is, I'm just going to multiply this minus inside. So it will be minus pi square. So pi square and pi square will get cancelled. So I'll get the remaining as minus pi, which is nothing but minus 2 pi. Okay. So now pi and pi will get cancelled. So the remaining terms will be minus 2 minus 1 power n by n. So Bn is equal to minus 2 minus 1 power n by n. So now we are finished with A0, An and Bn. Just we are going to expand the Fourier series formula. So now this is the Fourier series formula. What we are going to do is, we are just going to expand the summation up to 3 terms. Okay, that is, we have summation n is equal to 1 to infinity an cos nx. First we apply n is equal to 1. So we have a1 cos x. Then we take n is equal to 2, so it will be a2 cos 2x. Then n is equal to 3, a3 cos 3x. This will extend up to the last term, that is up to plus infinity. Okay. So likewise here also, when you are doing it for Bn also, it will be b1 sin x, b2 sin 2x, b3 sin 3x plus up to, it will extend up to the last term, that is infinity. Okay. So now I know the value of a. So it will be minus 2 by 3 pi squared by 2 plus 4 into cos x, that is a1 value. An is equal to minus 4 minus 1 by n whole power is there. So when I substitute a1, wherever I am having n, I will substitute 1. So it will be minus 4 minus 1 power 1 by 1 square, which is nothing but 4 by 1. Likewise, I substitute n is equal to 2, I will get a2 as minus 4 by 2 squared. When I substitute n is equal to 3, you will get 4 by 3 square. Likewise, I do same thing with my bn. So I will get b1, b2, b3. Okay, so now everything I'm going to substitute in this formula. So it will be minus 2 by 3 pi squared plus 4 cos x minus 4 by 2 squared cos 2x plus 4 by 3 squared cos 3x plus etc. up to, you will get up to infinity. And here same thing, you will substitute the value of b1, b2 and b3. Here you can see 4 is common, right? So I take 4 as a common term outside. So the remaining terms I write like this. And here also you can see all the terms are having 2. So take 2 outside. So this ends the problem.